All right, so in this lesson, we're looking at 7th grade, Module 1, Lesson 3, and then one problem from Lesson 4 so we can get that concept of proportional graphs. So in Lesson 3, we have our first problem where it says Nora takes daily walks. The distance Nora walks in miles is proportional to the amount of time she walks in hours. So we're not trying to find whether this is proportional or not because it tells us here that it is proportional. What we're trying to figure out is being able to determine how many miles Nora walks per hour. So we need to figure out what is the constant proportionality. That constant proportionality lets us know what is her unit rate. So constant proportionality is the same thing as a unit rate. It breaks everything down to 1. So for us to find that constant proportionality, we're going to look at our first row and act like this is its own problem. So we're going to take 1/4 and we typically multiply that 1/4 times the constant of proportionality. So this is our constant, which we represent with a letter K. Constant is going to be a letter K. So I don't really know off the top of my head what number would give me 3/4 if I multiply it times 1/4. So we're going to go the opposite direction and go from right to left. So we're going to start with the 3/4 and we're going to do the opposite of multiplication. We're going to go ahead and divide by the only other number they give us, 1/4. So if we go ahead and do keep, change, flip, we're going to keep the 3/4. We're going to turn division to multiplication, and then that 1/4 becomes 4/1. Then we go ahead and multiply. We've got 3 times 4, which is 12. 4 times 1, which is 4. And then this improper fraction is 12 divided by 4, which gives us a constant proportionality of 3. So our constant of proportionality is going to be 3. Now, if we were trying to see if this was proportional or not, we would multiply each of these numbers times 3 and verify that we get all of these numbers as answers to those 3 problems. If it is, this table is proportional. But again, we already know that it is proportional. So down the bottom, it just says use a method of your choice to determine the number of miles Nora walks. Well, we found it. It's the constant proportionality. So that means for that answer, we can write down that Nora walks 3 miles per hour. Nora walks 3 miles per hour. Moving on to the next one, you got a few different tables that ask whether they're proportional or not. We're going to go ahead and do the first 2, and the remainder I'm going to let you do on your own. I'll just go ahead and give you the answers. So in this particular problem, you can see that this is different than anything that we did in lessons 2 and 3 because it throws in not only decimals but also fractions. So we can't do problems with fractions and decimals. We have to convert one to the other. But in looking at this, if I want to find the constant proportionality, the row that I would concentrate on this case is this one down here because it's whole numbers. Now, if you wanted to, and you want to change them, change the decimals, and you want to do this top row right here, to change that into a decimal, your whole number 2 would stay at 2. The decimal, the fraction part of the mixed number would turn into a decimal. And yes, most people know that 1/2 is equal to 0.5. But let me show you how you get 0.5. 1/2 is really just the problem 1 divided by 2. So then 2 goes into 1 0 times. We would add our decimal and our 0, bring our decimal up. And 2 goes into 10 5 times. And that's how you would end up getting, or that's why 1/2 is equal to 0.5. So then you just turn that 2 1/2 into 2.5. Find that constant proportionality and go ahead and continue on down. But right here, we got whole numbers. So again, just like we did in that last problem, I don't know what number times 6 gives me 63. So let's go the opposite direction and do 63 divided by 6. So 6 goes into 6 one time. Going to give me 1 times 6, which is 6. We're going to bring our 3 down. 6 goes into 3 0 times. Gonna leave me with a remainder of 3 still. We had our decimal and our 0. The decimal goes up in our answer. 0 comes down, and that's gonna give me a 5. So we're looking at a constant of proportionality of 10.5. So let's go ahead and figure out if the rest of them is right. So go ahead and take that 2.5 and multiply it times 10.5. So 10.5 times 2.5. 5 times 5 is 25. Carry my 2. 5 times 0 is 0 plus 2. 5 times 1 is 5. Add my 0 for my next row. We got 2 times 5 is 10. Carry that 1. 2 times 0 is 0 plus 1 is 1. And then 2 times 1 is 2. We add this up. We got 2 numbers behind the decimal in our problem, so we need 2 in our answer. I get 26.25, which is the right number that we're looking for. The next one, I'm going to do 5 times the constant of proportionality, 10.5. So 10.5 times 5. Again, 5 times 5 is 25. This gives us a 2 and a 5. We got 1 number behind the decimal, so we get 52.5. And then the last one, we got 4/5, so we're going to change that to 4 point. We got 1 divided by 5, which goes 0 times. Add that decimal, and that goes 2 times into 10. So 4.2 is equal to 4/5. We're going to multiply that times 10.5. So 10.5 times 4.2. We've got 2 times 5 is 10. This is 1. 2 times 1 is 2. And our 0. 4 times 5 is 20. And 4 times 0 is 0 plus 2 is 2. And then 4 times 1. We've got 0, 1, 4, 4. 2 numbers behind the decimal in the problem. 2 numbers behind the decimal answer. We get 44.10. So let's see if we took care of that. It says for each table that represents a proportional relationship, write a description by using ratio language. For each other, explain why it does not have a proportional relationship. This one is proportional because it has the constant proportionality of 10.5. And if we were write using that ratio language would sound like this. And this is the sentence that you can write. For every hour worked, we would earn $10.50, which is our constant proportionality, our unit rate. The next table, if you scan through it, we got mixed numbers, we got decimals, and we have whole numbers. So let's go ahead and check that constant proportionality. We've got 260 divided by 4. So we're trying to find that missing number here. So 4 can't go into 2, can go into 26. It goes 6 times. 6 times 4 is 24. Gives me the remainder of 2. Bring that 0 down, and we get a constant proportionality of 65. So I'm going to go right up to the next number. I'm going to try 3.5 times 65. And I'm looking to see if I get 210. So we got 5 times 5 is 25. 5 times 3 is 15 plus 2 is 17. Add my 0 from the next row. We now got 6 times 5, which is 30. 6 times 3 is 18. And then 18 plus 3 is 21. We add this up. 1 number behind the decimal. So I get 227.5, which is not the same thing as this number, which means it is not proportional. And it is not proportional, as they want us to explain. It's not proportional because it doesn't have the same constant unit rate. It doesn't have 65 right here. This is not the constant for that row. All right, so now you can go ahead and pause the video, and I want you to do part C, D, E, and F on your own, trying to decide whether it's proportional or not. Remember, if it is proportional, explain why, find that constant proportionality. If it's not proportional, explain why, again, it's not proportional. So you can pause the video now, and then when you come back, I'll give you the answers. All right, so for table C, we're talking about loaves of bread and flour. or you have to use that ratio language I should have told you at the beginning. But anyway, this particular table is proportional because the pairs of values reflect the constant unit rate of 2 3/4. So you can use that as a constant, or if you want to change, if you change it as a decimal, that would be 2.75. And then using that ratio language that they want us to use, if it was proportional, would sound like this. For every 1 loaf of bread, there are 2 3/4 cups of flour, or for every 1 loaf of bread, there are 2.75 cups of flour. Letter D, this table also represents a proportional relationship because the pairs of values reflect a constant unit rate of 3. So if you did 1/4 divided by 1/12, you would get a constant proportionality of 3. Keep multiplying all those rest of those 2 rows and you would see that it was all proportional. That ratio language would sound like for every 1 hour, the distance walked is 3 miles. Letter E, the number of teachers to the number of students. This table does not reflect a proportional relationship because the pairs of values do not reflect a constant unit rate. You can see in the first row would be 1 times 5 would give you 5, but in the very next row, it's 1 times 4 would give you 4. So those are not the same unit rates. And then lesson table 5, that table does represent a proportional relationship because you have a constant proportionality of 20. So for every 1 hour worked, the amount earned is $20. Moving on to number 3, we're talking about Nora's summer job. It says Nora has a part-time summer job. The amount of money she earns is proportional. So again, we're not looking to see if it's proportional. Just let us know that. The table shows the amount of money Nora earns for different number of hours worked. And they want us to write an equation for part A that shows how much Nora can earn at her job. Let H represent the number of hours worked. Let D represent the amount earned in dollars. So, for us to be able to write an equation, 2 things have to happen. Number 1, it has to be proportional, which, as you can see right here, checks that off. It's already proportional. Number 2, we have to find the constant of proportionality. So if I'm looking at these rows, looks like the easiest one for me to do would be this one right here. So we're trying to find that constant right here so that we can write our equation. To do that, we do the opposite. We're going to do 57.50 divided by the number of hours, 5. So 5 goes into 5 one time. We bring down that 7. That also goes one time. Leaves us with 2. We have our decimal next, so I'm going to bring that up to the answer and bring this 5 down. 5 goes into 25 5 times. 5 times 5 is 25. And then we bring down the 0, and 5 goes into 0 times. So you see our constant proportionality is 11.50, meaning that Nora makes $11.50 per hour. So if we go to our equation, we're going to be doing the exact same thing you see that we just did that I have circled in red. What we did was we took the number of hours, which in that case was 5, and we multiplied it times 11.50. So we took the number of hours, H, because they say here let H represent the number of hours, and we multiply that, and we ended up getting the amount of dollars earned. So here they say let D represent the amount of money. So we did H times 11.50, the amount of hours times 11.50, and that gave us the amount of dollars. That is our equation, but we can write it a little bit better than H times 11.50 is equal to D. Because in algebra, this is going to look like a variable instead of a multiplication. So the way we write that better in algebra is like this. We take that coefficient, 11.50, and put it in front of the H. That means we're doing 11.50 times H, and that gives us our amount of dollars. Then part B, it says to use the equation from part A to determine how much Nora earns for working 3.5 hours. So I normally rewrite my equation, but since, well, I'll go ahead and just do it. We had 11.50 H is equal to the amount of dollars. And now they're telling us that the hours we should plug in is 3.5. Now my 11.50 is already as a decimal, so I'm going to write 3.5 as a decimal as well, replacing the H with 3.5. It's going to be equal to my dollars. Now we'll just go ahead and work that problem. 1150 times 3.5. We got 5 times 0 is 0. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. 5 times 1 is 5. Add a 0. We got 3 times 0. 3 times 5 is 15. Carry that 1. 3 times 1 is 3, plus 1 is 4. And then 3 times 1 is 3. Gives us 0, 5, 12. 5 and 4 is 9, plus 1 is 10. And then 1 and 3 is 4. We've got 1, 2, 3 numbers behind the decimal. So we need 3 in our answer. That means that she makes in 3.5 hours $40.25 is what D, the dollars, is equal to. All right, now let's go ahead and look at lesson 4 real quick. Lesson 4 was just the concept of what does a graph look like when it's proportional. So it was a bunch of just looking at graphs. We kind of looked at them, and once you understand the two reasons that a graph is proportional, these things are super easy. So in this one, number 4, all the number 1 through 3 was some activities that we did with some different graphs. So let's just go ahead and look at this one. We're going to plot these points that we have up here at the top. The first row is our x coordinate. The second row is our y coordinate. So for 0, 0, that's down at the origin. We don't move left. We don't move right or up. The next one we have is 1 and 1.5. So we go to the right to the 1. Notice each of these tick marks is half tick marks. So it represents a half. So we go over to the 1, and then we go up 3 tick marks to 1.5, which is right here. So 1 and 1.5. Then we go to the 2, up to the 3, and that's going to be right here. And then we have 5 and 7.5. So over to the 5, and then up to 7.5, which is right here. Now they want us to decide whether this graph is proportional or not. So to make a graph proportional, we need to have a line. So I'm going to go ahead and use a ruler and draw myself a straight line that connects all of my dots. So this particular graph is proportional, and it's proportional because of 2 reasons. Number 1, it's a straight line, and I'm trying to write with my finger, so it's kind of ugly. It's a straight line that includes all the points which, if you look at this line, it is a straight line, has no curves. All 4 points are on this line. The second thing that has to happen for it to be proportional, it must pass through the origin. It doesn't have to have a point at the origin. It just has the line has to pass through the origin. So when we drew that line, you can see that that line goes straight through the origin down here. So it meets those 2 requirements. So this is a proportional graph. If it was a line with a curve and it went through the origin, it still wouldn't be proportional because it didn't meet both requirements. Or if it was a straight line, but it didn't start until up here, like this line, that line is straight, but it doesn't go through the origin. So that line in particular is not proportional. All right, so that takes care of lessons 3 and 4. Lesson 5 was just a more practice of graphs, and then lesson 6 had to deal with equations.